RAG, Retrieval Augmented Generation. What is it? Why so many people are interested today into that? Well, let's take a deeper dive in this video. Retrieval Augmented Generation. We are going to go through the basic concept of this technique, which is getting increasingly popular. Everybody by now has used ChatGPT, right? How does it work? Well, I have a video about that. However, let's get a little recount. The prompt is simply what you write to ChatGPT, for example, or to Llama, anyway, to a large language model. How is a solar panel installed on a roof? For example, if you have to install one. You send it, you get a response. How does LLM work? What is it? LLM, we can think a big software. It's called a neural network that has been trained. Okay, training is a technical term. There is no real training, but has been adapted with a corpus, lot of documents, and we make it learn these documents. Say a library of books about solar panels. Well, great, LLMs are used now every day by more and more people, but they have limitations. First of all, the timeline. We can give documents up to a certain date, made the training, say, in 2021, but what if I need information which is after that date? So, no, the LLM will not give it. Actually, will hallucinate, we say. We'll give an answer, a made-up answer, on what has been trained on, which will be incorrect. Then, private documents. I cannot send them over the web and train it on private documents. So, no, red flag. And also, do I want to retrain it every time? That's a lot of time and a lot of money. So, not really efficient. Especially if I want to do that with my own documents. So, example, the training manual of the solar panel that I just bought. You see, if it's bought last month and has been, say, written 2 months before, 2 months earlier, LLM will not know it. That's where the RAG comes into play. Retrieval Augmented Generation. The answer augmented by retrieving information from documents that we give. But to give the documents, we need to store them somewhere. It's called knowledge store, this, based on documents that we upload. We give the user, we need something which is called a retriever that knows the documents and searches the relevant one. And then I augment the prompt with what is called the context, technically. It's a bit what I was doing when I demonstrated LangChain augmented with an agent. The agent was something that was connecting, a program was connecting to the Meteo website. I was asking about the Meteo in Brussels, so there was the prompt, the Meteo in Brussels, given that conditions are what the Meteo website was giving. And I was getting the final output. This is similar. Instead of the Meteo in Brussels, we just get knowledge from our own documents. How does it work practically? Upload the documents. Since the document may not just talk about solar panel or the topic that we are interested in, we need to split it into chunks. Imagine you have a book, has several chapters about solar farms, wind power, whatever, then we split it, and for each chunk we do a vectorization. We get the vector embeddings. Vector embeddings are these columns of numbers that represent the chunk and the tokens of the chunk. The tokens, we can think they are the words, okay? We have to index them, means to rank and to store them in what is called a vector database. Why we want to rank and index them? Because we want to retrieve them based on their meaning. Say this is my store, and I can index them according to the semantic meaning. For example, we can tell that the distance of apples to dogs is larger than the distance between dogs and cats, because these are animals. This is a living thing, but is an apple. You see, that's an example. Even farther away we have airplanes, which have nothing to do. So this is more distant to dogs and to apples than cats. And in this way we can retrieve them. The retriever, what does it do? Gets the prompt. The prompt, for example, is can I bring my cat on the flight to Paris? Okay, so I'm talking about cats and I'm talking about airplanes. Vectorization, I get embeddings of the prompt because my computer has to understand also the prompt. The prompt is not just, cannot be understood as words. So the tokens get their own embedding. Guess what? I measure the distance to the other vectors. My prompt, what I wrote here, is close to cats and close to airplanes. Right? I put it in the vector database. At that point I retrieve the tokens and the chunks which are closer to my prompt. And I get the context. Initial prompt, top number of chunks. We can select, for example, 3 chunks, 10 chunks. That is how you build your retrieval augmented generation. That is something that you can decide on. And you get an augmented prompt. It's like saying, what color is the white horse of Napoleon? No? We give already some information in the question. Send this to the generative model, and I get the answer, in this case an informed response. Is it possible using only Python code, using only open source? Yes, everything will work. In this case, I can think about putting my documents on Google Drive. Then I have to invoke a vector database. I can do it using code running, for example, on Google Colabs. I get the query, gets the closest chunks, gets to the LLM as we saw, and I get the answer. Do I want to show this time the code? Not really, because it's important that you get an understanding on how this works, and then you can put it in practice with code. Also because these retriever models, they will evolve, so that's a reason. And looking at code without fully understand what every block does is not very useful. Conclusion. We say that RAG, Retrieval Augmented Generation, allows users to question recent documents without retraining an LLM. And we cannot upload more documents, so updatable. This is possible with a vectorized knowledge database. You remember, cats, airplanes, and my prompt falls in between. Finally, RAG techniques improve very fast. There is a big drive to improve this process. Many business gets more and more interested about RAG. They want to get easily information about the documents, and they can see it as a help for experts, not a replacement for experts. Okay, I hope now you had a bit clearer idea and I thank you for your attention.